In this video, we'll take a look at Part 1, the Technology Lab, on how to use Desmos to graph a polynomial and then identify features of the graph. So the example that we have, the graph of the function f of x equals 2x to the third plus 7x squared minus 20x minus 70 is shown below, identifying the following. So how do we get that graph on Desmos, and how do we make sure that we can get Desmos to show the entire graph? So on Desmos, before we type it in, analyze the function just a little bit. You know that this is the graph of a cubic function and the leading coefficient is positive. So that tells you what the shape of your graph is going to be like. It's either going to look like the graph we have below, or it's going to be a constantly increasing function. So we want to be able to adjust the window on Desmos to be able to show that complete graph. So type it into Desmos, and I'm going to type it in, and then I'll share the screen. So we have y equals 2x to the third plus 7x squared minus 20x minus 70. So before I share the graph, there are some things that you can find. You can tell if you put a 0 in for x, that will give you the y-intercept. So f of 0 is equal to negative 70. So we know that our window has to go at least to negative 70. So I typed it into Desmos, didn't adjust the window yet, so let me bring it over. So there's the graph I typed into Desmos. You can't quite see the entire graph. So to adjust the window, click on the little wrench, Graph Settings. The x-axis looks fine. It looks like it's showing all the items from negative 10 to 10. The y-axis is not showing us the y-intercept. So I'm going to start at, let's see, I want to make sure I go at least to negative 70. So let's go to negative 80, maybe even negative 100. There we go, that looks a little better. And on the y-axis, I'm going to go ahead and go just to 10. Step is what do you want the graph to count by? The unit. So let's count by 10. And when you click away, there's our complete graph. A complete graph shows the intercepts, the relative maximum, y-intercept, relative minimum, x-intercept. So to have these points, notice that they're already on there. You can arrow over the top, and it shows you what the points are. If you click on the graph, or on each of those points, the point will stay there. And that's how you graph a complete graph in Desmos. So what you'll be doing is you'll be graphing the function x to the third minus 5x squared plus 3x plus 6. Adjust your window to make sure that a complete graph is shown. That means all of your intercepts and your zeros. And then after you do that, you will be able to identify your zeros, the y-intercept as a coordinate, and I'm asking for zeros as a coordinate this time, so these will be the full points, x, y. Relative maximum of the y-coordinate occurs at what x-coordinate? The relative minimum of y-coordinate occurs at what x-coordinate? And then the intervals where the graph is increasing and decreasing. So if you look above, I've identified the information. The increasing, decreasing, remember on the intervals, for this particular graph, it's negative infinity up to negative 3.5, but your intervals will be open. It doesn't, and you can't reach infinity, so that's always an open interval. And at negative 3.5, the graph isn't increasing or decreasing, it's changing direction, so that would be an open interval.